Your 3 minutes start now.
Okay, well, Sven already made the introduction, so I will have to go straight to the subject. I'm a climate modeler. I work in the Arctic. As some of you might know, the Arctic is a very, very sensitive ecosystem, which is particularly affected by, by climate change. It has been referred as a canary of the climate change. Why is that? Because it refers to the term that canaries were used back in the history by miner workers to really indicate how polluted was the environment in the mines. So if the bird got ill or if the bird was dead, the miners had to go immediately to the place. So that's what happened in the Arctic. So any change in the climate that is affecting the whole globe, it's particularly relevant for the Arctic. So why is this? Well, we got, as some of you know, we got CO2 and methane, other gases affecting, but there is another tiny particles called SLCPs, which is the term for short-lived climate pollutants. And I'm talking about black carbon, ozone, sulfates. So what happens is that all the pollution that is coming from lower latitudes are coming over the Arctic, and they are affecting the way that atmospheric processes are happening, about accelerating the ice melting. And this tiny layer of pollutants over the Arctic is being named Arctic Haze. And it has been observed in the 1880s by when the first explorers came to the Arctic, and they observed these tiny particles over the snow, deposited over the snow like dust. And they were very curious, so where did this come from? But it was until the 1950s that the first explorers, meteorologists, came and really observed this layer over the Arctic. So since then, in the last 40, 30 years, there have been massive exploration and massive studies about why pollution coming from everywhere about the globe, calling biomass burning from Asia, or industry, or any other economical activities from Europe, are affecting the Arctic, are being transported, and we can really notice that the changes that are happening in the atmosphere and in these places are really having a feedback effect over the lower latitudes, say extreme events happening like in Russia in 2010, or any other changes in coldest weather over Europe, for example. So it's important really to have a constant monitoring, a constant observation, modeling, to increase our knowledge about the Arctic and what is going to happen in the future. So that's all with my presentation. Yeah.